Alright, hello to the pairs of numbers of sum s problem. So, given two positive integers n and s, we have to count how many different pairs of positive integers, which are less than or equal to n and add up to s, exist. We have our example in which n equals 7 and s equals 6. So we have to count how many pairs of integers which are positive but no greater than 7 add up to 6. And the pairs are 1, 5, 2, 4, and 3, 3. There are a total of 3 of them, so this is why we return 3. First thing that I want to mention here is how important this word is, different pairs, because as you can see, I could have taken also the pair 4 and 2 and the pair 5, 1, right? But these are already taken into our answer with the pairs 2, 4 and 1, 5. So for this problem, we don't care about the order in which those integers appear in our pair. So the pair xy is the same as the pair yx, and we should be very careful to count it only once. So how to approach this problem? Well, the easiest way to do this is try out each and every pair of integers. So our idea looks like this. Try out each and every pair of integers x and y, such that first of all, these integers are positive and also less than or equal to n. So, such that x and y are part of this range, 1n. Then, for each of these pairs, we have to check one more condition, if these integers add up to s. So, we have to check whether x plus y equals s, and if so, count it into our answer. Because we only need to return the number of pairs, we will just increment the answer. So we will say answer plus equals 1, and of course answer can be a variable, for example, right, which is initially 0. Awesome, so all of these 3 lines can actually be very easily converted into code. The only problem is trying out each and every pair of integers x and y. Well, a pair of integers is actually determined by the values of the two numbers inside the pair. So, we first need to know what is going to be the value of x, and then what is going to be the value of y. X can take any value between 1 and n. There are going to be pairs which have the first integer 1 and some second integer. Also, there are going to be pairs which have the first integer 2 and the second one some integer, or the first integer could be 3 and some second integer, and so on and so forth. There are going to be pairs in our solution which will have the first integer n and some second integer. In order to count all the pairs that are possible to be part of our solution, we have to try out each and every value of x between 1 and n. And because the value of this n is not always the same and can be pretty large, we are going to do this using a loop. And because everything is so simple, the first value is 1, the value always gets increased by 1, and the last value should be n. The best way to do this is using a for loop. Let's see how that for loop looks like. And this is how that for loop looks like in pseudocode. We are trying out each value of x between 1 and n. This is obviously not enough, because a pair of integers needs 2 integers in order to exist. So we need to know what is going to be the value of this second integer. And because y can take any value between 1 and n, we are indeed going to try out each of these values, right? Because we can have pairs with 1 first integer and the second one to be equal to 1, or pairs with 1 integer and the second one equal to, and so on and so forth. 1 first integer and the second integer to be n. So we are also going to try out each possible value of y, starting from 1, always increasing that value by 1 until the last value, which is n. And this is how the second for loop looks like in pseudocode. Now, obviously, these two for loops won't be separate, because if they are separate, then I'm going to do something inside this for loop for each value of x between 1 and n, and then I'm going to do something inside this for loop for each value of y between 1 and n. But we don't want that. We want to do that quote-unquote something for each value of the pair consisting of the integers x and y. So for each value of x that I'm going to try out, I also need to try out each possible value of y. So these two for loops should be nested. Now this looks better. Now for each value of x, I'm going to try out each value of y. So inside the first for loop, here, we only know the value of x. But when we also enter this for loop and try out the current value for y, here inside the second for loop, we know both values, x and y. So only here I know the pair xy. So I'm going to check here if they add up to s, and if so, increment our answer. And this is how the whole pseudocode looks like. So for each value of x and also for each value of y, now that I know the pair xy, I can check if they add up together to s, and if so, increment my answer, which is initially 0, and of course in the end will be returned. Alright, this is how the code will look like in JavaScript. Don't worry, I know this algorithm is not correct, but let's just simulate it on an example to figure out together why. So I'm going to take as an example, let's say n equals 4. And s equals 5. Initially, we have our answer, which is equal to 0. So let's write s equals 0. And now we start the first loop, right? And x is initially equal to 1. So the value of x is going to be 1, which is less than or equal to 4. So we enter the second for loop, and y is going to be equal to 1. So y is initially 1. We execute what's inside and we check 1 plus 1 equals 5. No, so the answer is not going to be incremented. What we do is move to the next iteration and set the value of y to be now 2. 1 plus 2 equals 5. No, so move to the next iteration. Y equals 3. 1 plus 3 is not equal to 5. Move to the next iteration. Y equals 4. And now 1 plus 4 equals 5. So we have found our first pair. We will increment the answer, which is 1. And I'm just going to remember, let's say here, that I counted the pair 1, 4. Awesome. Now, after executing this, we'll move to the next iteration. Y gets incremented. So y is now equal to 5. And as you can see, 5 is not anymore less than or equal to 4. Our condition is not satisfied. And we are going to exit this second for loop. And when we do, we have seen that we have finished all the code inside this first loop. So we will move to the next iteration of the loop, which is x equals 2. So now we have x equals 2. We will enter again the second for loop. The first value of y is 1. So y is initially 1. And we check 2 plus 1 equals 5. No. So we do nothing. Move to the next iteration. Y gets increased equals 2. 2 plus 2 equals 5. No. Next iteration. Y gets increased. 3. 2 plus 3 equals 5. Yes. So I'm going to increment our answer. Answer is now 2. And I counted the pair 2, 3. Then move to the next iteration. Y becomes equal to 4. And as you can see, 4 is still less than or equal to 4, which is good. But 2 plus 4 is not equal to 5. So we do nothing. And we move to the next iteration. And y becomes now equal to 5. And this is it. 5 is greater than 4. The condition is not satisfied. So we are going to not execute this for loop anymore. We will exit it. And we'll move to the next iteration here. So x equals 3. And guess what? The exact same thing is going to be happen. Y is going to be initially 1. It will go all the way until 4, always being incremented, right? So I'm going to have y equals 1. Nothing happens. Y equals 2. That's good. As you can see, 3 plus 2 equals 5. So I will take into account the pair 3, 2. So you can already notice why our algorithm is wrong, because we have just counted the same pair for a second time. And y becomes 3, nothing happens. 4, nothing happens, becomes 5. The condition is not satisfied anymore. So we break out of this for loop. And of course, the last iteration where x equals 4, the exact same things happen here, right? Y equals 1. 4 plus 1 equals 5. So we will also count the pair 4, 1, which has been already counted here as 1, 4. This is the second time we do this mistake. And then, of course, we just increment y. Nothing's going to happen inside because our sum is greater than 5. And when y becomes 5, we exit this for loop and we make another incrementation. X equals 5, but this time 5 is greater than 4 and our algorithm is going to stop. We are going to exit this for loop and we will return the answer, which is 4. Sorry about that. I forgot to increment the answer, which is 4. So as you can see, everything is fine. We indeed try out each and every pair of integers less than or equal to 4, because these values of 5 weren't even taken into account, right? We try out 16 pairs in total, but as you can see, we count some solutions twice. For example, this one with this one, and this one also with this one. And my question is, how can we avoid this? How can we avoid counting the pair where x equals 1 and y equals 4, and also the pair when x equals 4 and y equals 1? Well, as you can see in our algorithm, each different pair of integers is actually tried out twice. Some pair of integers, for example this one, 2, 3, is going to be tried out first when x equals 2 and y equals 3, and then when x equals 3 and y equals 2. In order to avoid this, we can make sure that we only count one occurrence of this pair, and that occurrence is going to be the one in which the value of x is the smallest one. So if the values in our pair are 2 and 3, we have to make sure that the smallest one, which is 2, is going to be the one that x will take, and the other one is going to be taken by y. In other words, we have to make sure that whenever we try a pair x and y, x will always be less than or equal than y. In this way, when dealing with pairs such as 2 and 3, we know that x can take the value 2 and y can take the value 3 because the condition is satisfied, but x taking the value 3 and y taking the value 2 is not accepted anymore. Also, for pairs of equal elements, for example the pair 3 and also 3, at some point x is going to take the value 3, right, in this first for loop, y is going to take the value 3, but this is never going to happen again. So the only thing that we have to make sure is that x is always less than or equal to y. One way of doing this is, of course, writing another condition in this if statement. We can check if x is also less than or equal to y and x plus y equals s. And I think in JavaScript, this is the end. Awesome. If we do this, we will make sure that the answer will always have the correct value. But why do that when I can do something that's way easier and will even reduce the total number of iterations my algorithm is going to do? Remember that in a for loop, we always initialize the variable first. So if I really want this variable to be always greater than or equal to x, as I know my variable is always going to be incremented, the only thing I need to do is just initialize y with x. So let's remove this piece of code and let's just initialize y with x. And this is it. Now, if we take a look at the simulation, when x equals 1, y will be initially equal to 1 and always get incremented until the value 4. So this is still going to be correct. When x equals 2, y is initially 2 and goes all the way to value 4. So this value is not taken into account anymore. When x equals 3, these two values of y are not taken into account. When x equals 4, these two values are not taken into account. So as you can see, all the pairs that we are taking now into account are actually distinct. And even more than that, we have reduced a lot the number of iterations as we don't try out these values for y anymore. And this is it, guys. There are at least two more solutions to this problem. One is based on the fact that if we know x plus y equals s, then if we know the value of x, there's no point in trying out each and every value of y because y should be equal to s minus x. So we can only check if this is part of the range 1m. And there is even one more faster solution. We can even come up with a formula based on m and s to compute the number of pairs. But that's not the point here. What I want you to do is really make sure that you understand how two nested loops work together, because in a lot of problems, we are going to need them.